Continuing on with the review, number 23, I want to solve the polynomial inequality k minus 8 times k minus 3 times k plus 2 less than 0. I have 0 on the right hand side, which is good. I want that. Now I need to set each factor equal to 0 and solve for k. I get k equal 8, k equal 3, and k equal negative 2. Putting those on my number line, negative 2 is on the far left, 3 is in the middle, 8 is on the right. Now I'm going to pick values in each of these intervals and plug them in to my original polynomial. If I were to plug in, say, negative 5, so a number here in this interval, and I plug negative 5 times minus 8 times negative 5 minus 3 times negative 5 plus 2, I will get a negative number. I don't care what that number is, I just need to know if it's negative or positive. If I plug a value in from here, between negative 2 and 3, I'm going to get a positive number. If I plug a value in here, I'm going to get a negative. If I plug a value in here, I'm going to get a positive. It does not always alternate, guys. You need to check it. Okay, I am looking for values that are less than 0. These were where they were equal to 0. I do not want those. There's no equal to up here. Open circles on those. The less than 0 correspond to the negative numbers, so they're going to be this interval and this interval. So my answer will be negative infinity to negative 2 with a parenthesis, union 3 to 8. Number 24, solve the rational inequality x minus 6 over x plus 3 less than or equal to 0. Again, we have 0 here on the right hand side. That's what we want. We need to set the numerator equal to 0 and solve for x. X minus 6 equals 0, so x equals 6. We need to set the denominator equal to 0 and solve for x. We get x equals negative 3. So on our number line, I need to put negative 3 and 6. Now negative 3 was where the denominator equaled 0. That's always an open circle. Then I look at my inequality. I want less than or equal to 0. So equal to 0 is here. That's going to be a filled in circle. Okay, we have to go find our pluses and minuses. If I plug in, say, x equals negative 10. Negative 10 minus 6 over negative 10 plus 3 gives me negative 16 over negative 7, which is a positive number. If I plug in 0, so 0 is in this interval, 0 minus 6 over 0 plus 3, I get a negative number. And if I plug in a number to the right of 6, I'm going to get a positive number. I want all of the numbers that are less than or equal to 0, so I want these numbers. My answer would be parenthesis negative 3 comma 6 with a bracket. Number 25, given the function that's the set of ordered pairs here, I want to find the inverse. How do you find the inverse? You switch the x's and y's. So my inverse function would be negative 9 comma 10, negative 8 comma 8, negative 7 comma 6, and negative 6 comma 4. That would be my inverse. The domain of the inverse are going to be these numbers: negative 9, negative 8, negative 7, and negative 6. The range, let's do another color. The range of the inverse are going to be the y values. So they are going to be 10, 8, 6, and 4. Number 26, given f of x equals 7x squared minus 3, and you're restricting it to x's greater than or equal to 0. Find the inverse. Because of this restriction, we know that f is 1 to 1, so it does have an inverse. How do you find it? Well, this says that y equals 7x squared minus 3. First thing you do is switch the x's and y's. So x equals 7y squared minus 3. Now solve for y. I need to add 3 to both sides. I get x plus 3 equals 7y squared. Then divide both sides by 7. X plus 3 over 7 will equal y squared. To get y by itself, I need to take the square root. But when I take the square root of the left-hand side, I have to put plus or minus out front. Now, which one did I want? Since I wanted my x's greater than or equal to 0, I need to choose the plus square root. So my inverse function is positive square root of x plus 3 over 7. Number 27, given that 5 to the negative 2 equals 1 over 25, that's in exponential form. I want you to convert that to logarithmic form. You're going to write log base 5 of the number 1 over 25 is equal to negative 2. Number 28, if I give it to you in logarithmic form, log base 16 of 2 equals 1/4, and you have to put it back into exponential form, you're going to have 16 to the 1/4 is equal to 2. Number 29, graph f of x equals 2 raised to the power of x plus 3 minus 1. The parent function is y equal 2 to the x. Your three favorite x values are negative 1, 0, and 1. When x is negative 1, you get 1/2. When x is 0, 2 to the 0 is 1. When x is 1, 2 to the 1 is 2. So your parent function, negative 1, 1/2, 0, 1, and 1, 2. Your parent function looks like this. But you want to shift it 3 to the left. So your x values, you want to subtract 3. And you want to shift it down 1. So your y values, you want to subtract 1. So here we go. Negative 1 minus 3 is negative 2. 0 minus 3 is negative 3. 1 minus 3 is negative 2. For my y values, 1/2 minus 1 is negative 1/2. 1 minus 1 is 0. And 2 minus 1 is 1. So my new function here is going to be the point negative 2, negative 1/2, negative 3, negative 1, back up, quick mistake. Negative 1 minus 3 is negative 4. Sorry about that. Go fix that. Your point should be negative 4, negative 1/2. Then you have the point negative 3, 0, and the point negative 2, 1. So your function should look like this. Notice that the original horizontal asymptote of y equals 0 has been shifted down 1. So your new horizontal asymptote is y equal negative 1. I want to expand log base 4 of x minus 5 over x to the 4th. To get rid of the division, I have log base 4 of x minus 5 minus log base 4 of x to the 4th. You cannot do anything to this. It stays. However, the x to the 4th, that exponent can sprout legs and walk out front. So I get log base 4 of x minus 5 minus 4 times log base 4 of x. Number 31, I want to condense 8 log base 9 of m minus 6 log base 9 of n. These numbers out front are going to come back up as exponents. So I have log base 9 of m to the 8th minus log base 9 of n to the 6th. To get rid of the subtraction, I need to do division. So I get log base 9 of m to the 8th over n to the 6th. Number 32, I want to solve 2 to the 5 minus 3x equals 1 over 16. I know that both of those sides can be written as powers of 2. So 2 to the 5 minus 3x is equal to 2 to the negative 4. I can get rid of my bases. And I have 5 minus 3x is equal to negative 4. Subtract 5 from both sides. Negative 3x equals negative 4 minus 5 is negative 9. Divide both sides by negative 3. Negative 9 over negative 3 is 3. Number 33, solve log base 6 of x plus 3 equals 1. I'm going to convert this to an exponential. So I get 6 to the 1 is equal to x plus 3. So if 6 is equal to x plus 3, I need to subtract 3 from both sides. 3 is equal to x. If I plug 3 in for x, I will get the log of 6. Can I take the log of a positive number? And the answer is yes. So that solution works. Number 34, I want to get log base 10 on both sides. So first thing I need to do is condense the right hand side. So I have log of 3x is equal to log of 5 times x minus 4. And why did I do that? Because I had a plus here. So I need to multiply 5 times x minus 4 when I write it as a single log. Now I can get rid of the logs because I have log on both sides. I'm using the property that says log m equals log n implies m equals n. That's the rule that I'm using right now. So I know that 3x is equal to 5 times x minus 4. 3x is equal to 5x minus 20. If I subtract 5x from both sides, I get negative 2x is equal to negative 20. Divide both sides by negative 2, I get x equals negative 10. If I plug negative 10 in, x equals positive 10. And why? I'm dividing both sides by negative 2. So x equals positive 10. If I plug 10 in, I'm going to take the log of 30. That's okay to do. And I'm going to take the log of 6. That too is okay. So yes, that is a good solution. Number 35. 6 to the 3 minus x equals 24. I'm going to take the log of both sides and I'm going to take log base 6 of both sides. So I get log base 6 of 6 to the 3 minus x equals log base 6 of 24. And I did that because the right hand side will now be 3 minus x is equal to log base 6 of 24. So if I add x to both sides and I subtract log base 6 of 24 from both sides, my answer will be 3 minus log base 6 of 24, that's gone, equals x. (36) is a word problem. It says that the population can be modeled by this equation. And it said when, solve for time, when will the population be 2400? So I set 2400 equal to 800 e to the 0.19 t, and I want to solve for t. First thing I need to do is divide both sides by 800. 2400 divided by 800 is 3, and 3 will equal e to the 0.19 t. Now take the natural log of both sides. I get natural log of 3 equal to 0.19 t. Dividing both sides by 0.19, I get natural log of 3 over 0.19 equal to t. And when I typed it in on the calculator, I get approximately 5.78 years. Number 37 gives me a system of equations, and it wants me to write the augmented matrix. All I need to do is write the coefficients in a matrix. So I get -5, -6, 9, 5, -1, 4, 0, because there aren't any z's, -6, 1, 0, -7, 4. That's the augmented matrix for this system. For 38, I'm given this system. I need to write those equations in standard form first. And when I do, when I write this one in standard form, I need to move the 7x to the left, and I get 7x minus 5y equals -22. When I write this equation in standard form, I distributed the -4, and then I added y to both sides. So I got -4x plus 9y equals 31. I'm going to use this equation and this equation because those are both in standard form, and I'm going to write the augmented matrix: 7, -5, -22, -4, 9, 31. On my calculator, I store this as my matrix, and then I go do RREF of that matrix, and the answer it spits out is 1, 0, -1, 0, 1, 3. Here's my solution. The answer is the ordered pair -1, 3. Similarly, number 39, here's the system of equations. I want to write that as an augmented matrix: 1, -1, 1, -1, 1, 1, 1, -5, 1, 1, -1, 3. If I put this in my calculator and say RREF of that matrix, I come up with this matrix. Here's my solution. The solution to that system is the ordered triple: 1, -2, -4. Number 40, if I give you this matrix that is in row reduced echelon form, you notice that the bottom row is all zeros, so you know that there are infinitely many solutions. I want you to give me the formula to find all of those solutions. So this top row tells me that x plus 9z is equal to -9. So x is going to equal -9 minus 9z. The second row tells me that y plus 8z is equal to -2. So y is equal to -2 minus 8z. My solution will be of the form -9 minus 9z, -2 minus 8z, z.